One thing that we want to make sure when we are using aggregation, we have to make sure that we don't leave holes for things to outside forces to kind of come in and change things. For example, here's a bad constructor. So if we were to say in the course, we're going to basically bring in a string, the instructor object and the textbook object. And then down here we just said instructor is equal to the this instructor being brought in object. Here's what's problem is this is what's called a shallow copy, and it can cause a security hole. What that means is this guy can still be modified outside of this class. So what happens is we don't have total control over this instructor right here, because this guy is created and utilized outside of this class. So we need to make sure we avoid those. Again, we always want to make sure that we have control over everything inside of our class. We don't want to make sure that nobody outside of this class has access to that. So otherwise we'll cause what's called a shallow copy. Also, we want to make sure that we return copies of the field objects, not the originals. So here it says when a method of the aggregate class returns a reference to a field object, it should return the reference copy to the field object, not the field object itself. So for example, we look here, I've got public instructor, get instructor, return new instructor, instructor. Notice return statement uses the new keyword. We are creating a new object, and that's what we are returning. We do not want to do this where we say return instructor. Again, that can also cause a security hole. This is the object that is created is a copy of the object referenced by the instructor. So we are returning a copy. We always want to return a new object. Okay, so just a couple of different security measures we always want to make sure that we avoid and as to not cause issues where things outside of our class can change our particular class that we're dealing with. Another thing we want to avoid is using null references. So let's go ahead and take a look at full name. So we take a full, so here we have full name. We have three instance variables, last name, first name, middle name. We do not have any constructor, but we have a set last name. So we bring in a string, we set that, first name, middle name. Then we have get length. So return last name dot get length, first name dot get length, and middle name dot get length. And then we have a toString. Okay. So what we're going to then is we're going to use what's called the name tester. Let's open that up. And if we look, we've got int len, and we say full name, name. So we create our name object from the full name class. And then I say len equal name dot get length. Now notice we did not set anything inside of this full name. So watch what happens when we run this. We get an error. It says because this has a null value. You cannot get a length from a null value. So what the books suggest that we do in this type of a case is here in our get length, we should do something like this. We should say int len equals 0, and then come down here and say if last name is not equal a null value, then we're going to say len equals last name dot length. And we'll do the same thing for the first name. And the middle name. And then what I'm going to do, I'm going to comment that one out, and I'm going to say return len. So no matter what, len gets set to 0 right off the bat. Then we go and say, if the last name's not equal null, we're going to then, oh, I need to do a plus equal, sorry. If last name's not equal null, then we're going to add the length of last name to len. Same thing for first, same thing for middle. So no matter what, len will get returned. So now when I go back over here to name tester and I run it, it comes back and it does anything because it brought it. So what we needed to do is this. I should have done a SYSO and then just basically printed length len here. And now when it's ran, it basically returns a 0 because so these are the things we have to think about. Is we always have to think about when can there an error arise from the code that we have. If we get rid of this guy, nine times out of 10, this is going to work. This will work 9 times out of 10 because we're most likely always going to have something in one of these names. But just in case there's ever a situation where there could be a null value in there, we always want to make sure that we code for those types of things. Another thing the book talks about is making sure, and I've talked about this before as well, is making sure that we use the this. Always use the this to overcome what's called shadowing. And I've covered this in a previous chapter. But again, we always want to make sure that when we are dealing with a class, that we don't have to do this, but using the word this dot will always assure that we're using the instance variable for this class. So just in case we might have something like this where we had now we know that this last name here goes with the parameter that was brought in, and we know that this last name goes with the instance variable last name because we use the word this in front of it. Do we have to always use it? No, we don't have to, but it's probably a nice safe bet to make sure that we always are using our instance variables by using this to basically overcome shadowing. We can also do the same thing when we use constructors as well. So we can use this to call an overloaded constructor from another constructor. So in this case here, we've got stock and stock string symbol. So bringing in a string and a double, and we've seen this in our current stock class we're using. And I say symbol equals sim, share price equals sim. We could also do this. I could say public stock. So the constructor accept arguments that are assigned to the symbol and share price fields. Let's suppose we want to construct an only accept argument for the symbol field and assign 0.0 to the share price. So we could do something like this. I could say public stock string sim, bring that in, and then I can say this sim, comma, 0.0. I don't like this so much because it's kind of confusing what's going on here because I know that the sim is going to set the instance variable for symbol, and the 0.0 will get the price. If I were to do something like this, I would say symbol equals sim and share price equals 0.0. I would do something like that if I wanted to use that type of a constructor. It seems it's a little more straightforward and easy to read. But again, this is available. You can use that. Okay, the next part of this chapter talks about this things called enumerated types. An enumerated type consists of a set of predefined values. So these are things that are already have a value in there. And we can use this data type to create variables that hold only values that belong to the enumerated data type. So here's our example. I can type enum day, so enum is a reserved word, and now we created the enumerated type day, and it's got Sunday, comma, Monday, comma, Tuesday. Notice they're all inside of braces. Now the reason we use uppercase letters is these are considered constants. So we always use the uppercase letters for enumerated data types because they are constants. And that's what it says down here. It says, we're making up the names of enum constants as required. If you're written all uppercase, we could have written day types, enum consistents as Sunday, Monday, and so forth. Because they represent constant values, we always write them in uppercase. So let's take a look at an example we've got. And let's look at enum demo. Well, you know, let's talk about, so in this particular case, we've got a workday variable, and it references the dot Wednesday object. Okay, so here I've got day workday, and day workday equals day dot Wednesday. Notice that we assign the dot Wednesday instead of just Wednesday. When you write a enumerated data type declaration, you're actually creating a special kind of class. The enum constants that you list inside the braces are actually objects of the class. In the previous example, day is a class. The enum constant day.Sunday through Saturday are all instances of the day class. So they all are instances, but basically they are constants. So each of these objects in the day type, which is a specialized class, and workday is then holds the address. So when we say up here, workday equals day.Wednesday, it now holds the address of day.Wednesday, that instance. And so when I say sysout print workday, it's going to print all uppercase Wednesday. Now we also have another thing too, is each one of these guys has an index assigned to it automatically, and it's just like a list. It's zero, so in this particular case, it's 0 through 6. Now it's not called index; it's actually called an ordinal. Okay, and we'll see how that works here in a few minutes once we start playing around with it. But we can say last workday equals day.Friday, and then we can print the last day.Ordinal. Now you notice it's got parentheses around it, so it is a method built into the enum enumerated type. An ordinal value for Friday is 5, and an ordinal value for Monday is 1. So this code will display 5 and 1. So when it says print the ordinal value for workday or day.Monday ordinal, it'll actually print 5 and 1 in those particular cases. So again, so let's take a look at enum demo. And so here we've got the enum day and Sunday, Monday, Tuesday, all the way through Saturday. And notice that this is a global variable, so it's going to be a global enumerated data type. So it's going to be able to be used by anything inside of here, which there's only one method, so it doesn't really matter. So we got our public static void main. We say day workday equals day Wednesday, and I print that out. And then I say the ordinal value for Sunday is Sunday.Ordinal. Notice I say day.Sunday. And then down here I say ordinal value for day Saturday is day.Saturday.Ordinal. I can do the same thing. Now I can say if Friday.Compared to, now this is a built-in method, okay, for the enumerated data type. And I can say if Friday compared to day Monday is greater than 0. Now I'm saying the compared to is built into the object class, which is, I think I've talked about this before. There's one major class called object, and all of the other data types inherit from that. And so compared to is one of those methods that's part of that. And what it does is if they're equal, it's going to be compared to will return a 0. If one is greater than the other, it's going to return a 1. If it's less than the other, it's going to return a -1. I think I've covered this when we were looking at string data types. So when to compare Friday to Monday, if it's greater than 0, we're going to say Friday is greater than Monday. Else, we're going to say Friday is not greater than Monday. They could be equal to. Well, Friday, the ordinal value of Friday is a 5 and Monday is a 1, so it should say Friday is greater than Monday. So let's run this. And sure enough, up here it says print the workday, which was Wednesday, so there's Wednesday. The ordinal value for Sunday is 0, so right here. The ordinal value for Saturday is 6, which is this out right here. And then Friday compared to Monday, Friday is greater than Monday. So some different ways we can utilize the enumerated data type. So let's see it in a different format. Let's open up car type. So car type is just boom. Look at that. That's it. That's all there is. We can say enum, car type, Porsche, Ferrari, Jaguar. Let's look at car color. Same thing. It's a standalone class all by itself, and it's just got enum, car color, red, black, blue, silver. So what we're going to then do is see how can we utilize these two classes, and we're going to open up sports car. And there we've got private car type. Here's car type. We bring it in as an instance variable, and it's got make, and then private car color, color. Again, that's the enumerated data type over there. So it's kind of like aggregation. And then private double price. Then we come down here and we've got our constant, or constructor, where we bring in car type, car color, and double, and we set each one of those different items. And then we've got car type get make, return to make. Notice it's returning a enumerated, the class enumerated car type. Same thing with car color, and then with the get price, it's returning the double. And then we have a toString. We create a decimal format, and we say string make is make, color is color, and price is the dollar format price, which is this one's a dollar sign right here, and it's going to be in the thousands separator and 0.00, so it's going to round to the 2 decimal places. We return the string, so when we print this class, we'll basically print that toString. So if we look at car string demo 2, or car sports car demo 2, so here's where we utilize it all together. So we create a new sports car object. It's called your new car, and it's got car type Porsche, car color red, and it's $100,000. Now we use a switch, and we say your new car.getMake. Case Porsche, your car was made in Germany. Case Ferrari, your car was made in Italy. Jaguar, England, and then default is I'm not sure where that car was made from. So when we run this, your car was made in Germany. Now, we could do something like this at the very end, and I could have said sys o your new car, and that would have then kicked off that toString. There it is. Your car was made in Germany. Make Porsche, color red, price $100,000. Yeah. Okay. Now on page 540, we do have this thing called garbage collection. So let me get that up on the page here. So the JVM, or the Java Virtual Machine, actually will run this thing called garbage collector, and we have no idea when it's going to be ran. And so basically when an object is no longer needed, it's actually sitting there, still sitting in memory. And what happens is the garbage collector will come along and just wipe out that part of memory. Again, we don't know when it happens. So when an object is no longer needed, it should be destroyed, so memory it uses can be freed for other purposes. Fortunately, you do not have to destroy the objects after you finish them. The Java Virtual Machine, the JVM, performs a process known as garbage collection. which automatically removes unreferenced objects from memory. For example, look at the following code. Bank account, account 1, account 2. So we create two bank account objects. Again, right now they're just shells. And we got account 1 equals bank account 500. So the constructor is going to create a balance. And account 2 is equal to account 1. And again, now we have just basically one object with two name tags. And then we say account 1 equals null. And the object is still referenced by account 2, though. The store null in account 2 is no longer referenced to the object, so account 2 equals null. Now the object is no longer referenced, so it will be removed by the garbage collector. So what will happen is, once these two items are set to null, and they're basically sitting out there in memory, that garbage collector, again, it runs periodically, will come in and wipe that part of memory out, because it says, hey, we no longer need this because this object is no longer in use. Yeah, so they both point to 500. The account 1, it no longer, it's now null, but object 2 is still referencing that bank account object with 500. And then once that is set to null, now the garbage collector, now it's inaccessible and removed by the garbage collector, because it has a null data type and set to it. Okay. One thing is, if a class has a method named finalize, it is automatically just before the instance of the class is destroyed by the garbage collector. If you wish to execute code just before an object is destroyed, you can create a finalize method in the class and place code there. So we could do something like this in our, I'm gonna use the full name, is I could come down here at the very bottom. It can be anywhere, but I'm gonna put it at the bottom. I'm gonna say public. I can make it private too. Public void finalize. And I'm just going to do a sys-o. Okay, so I'm going to run this and let's see what happens. So when I go into name tester now, oh, I got the old code in there. So I got to basically uncomment this code right here. Hold on a sec. Let's try it again. Let's see. I think we have to. Let me try this, and I'm going to say name equals null. Let's see if that will do it. Now it's, hold on. Well, apparently having a hard time. I guess we, since we can't control garbage collection, there's no way to get that finalized to kick off like that. So, So I'd have to just, hopefully have to find out a way to hard code some kind of a garbage collection in there, force it some way. So I'm sorry, can't show an example of the finalize, but again, if you needed to do something before garbage collection took care of that, whatever was in memory right there, it's supposed to basically be able to kick off and do things. So, okay. So the next part of the chapter talks about focus on object-oriented design and class collaboration. It's common for classes to interact or collaborate with each other to perform their operations. Part of the object-oriented design process is identify the collaborating among classes. So basically what they're saying is this. Let's take a look at the code. So we're going to use this stock purchase package, and we're going to look at the stock purchase. So first, let's take a look at the stock. This is I think this is the same stock we've been using. We got two instance variables, a string symbol, a double share price. Here we got our stock. We basically bring in a symbol and a double, and we basically load those two instance variables. We've got stock. So we're bringing in a stock object, and we're taking whatever the object is. We're taking the symbol and putting in our symbol, and the share price from that object, putting that. Again, we want to make sure we're not basically too shallow. We want to make sure that we control. This is our object that we control. Nobody outside of this class can control it. And that's what we're doing here. Instead of just basically making it equal to that symbol, we're making. I'm sorry. Instead of making sure that we're saying this class is equal to that class, that's shallow because now people can control that class outside of our class. We basically say that symbol is equal to that object symbol. So we're basically copying the symbol and putting it into ours, copying that share price, putting it into ours. We got get symbol, our get share price. Here's our toString. Here's our equals to see if things are equal. And then we have a public stock copy. So if we want to create a new stock, we can say stock copy object equals new stock symbol and share price. And then we can return this. So this will return a stock object. It's going to take our existing symbol and share price and copy it into a new stock object and then return that. So if we take a look at the stock purchase, so this is a stock purchase. It has two instance variables, stock and number of shares. And here's our stock purchase, and it's bringing in a stock object and number of shares. Now look at this. It instantiates a new stock object called stock. And so this stock up here, we load it. We load it with the stock object that basically came from over here. So again, going back to stock over here, that's what basically is going on right there. Equals new stock object, and it returns a stock. Well, we're not actually calling the copy, sorry, but so that's basically what's going on there. In our stock purchase, we are taking the stock object itself and creating a new stock object from that and the number of shares. We've got the same stock get stock, except look at this. What we're doing is public stock get stock. So we're actually returning a stock object. We're instantiating a new stock object from our stock and returning it. So we're making a copy. This is another way to make a copy. Get shares, get costs. This is kind of cool. What we're doing is saying we want to get the cost. We're going to take the number of shares, multiply it times the number of stock, and get share price. So we're going to grab the current share price that is with our stock and multiply it times the shares, and then return that as a double. If we look at, what do we want us to look at first? Stock Trader. So let's look at Stock Trader, see how it all works. Okay. So basically what they really want you to know is making sure we don't basically have shallow objects. We basically are very secure, and that we are basically having control over our class and not basically letting that security leak out. And that's really what the whole purpose of this last section is. So if you look at Stock Trader, we've got int shares to buy. We've got our stock, so we're creating a new stock object called XYZ Company, and it's instantiated as a new stock, XYZ 9.62. We got our scanner keyboard, and we print XYZ stock is currently $, so we're using a printf, and it's 2 decimal places, comma separated, and then /n XYZ company.get share price. So it's going to grab that current share price that's up here, 9.62. Then how many shares do you want to buy? We grab that from the user. And then we create a new stock purchase object called buy, and we're going to instantiate it as a new stock purchase, and we're going to bring in the XYZ stock object, company stock object, and shares to buy. And then system out, the cost of the stock is, and we're using a printf again, buy.get cost. So now so remember that stock purchase, the very bottom, that get cost, that's where it multiplies the shares, and stock.get share price. So when we run this, the XYZ stock is currently at 9.62. How many shares you want to buy? We're going to say 10 just to make it easy. And the cost of the stock is 96.20. Again, the emphasis on this is making sure that we have total control over our objects. Okay. We also have stock demo 1. And so this guy here is creating a stock object called XYZ company, XYZ 9.62. And we just go ahead and print out the company. And we've seen this before. It's just going to call that print. Yep. Okay. That's pretty much it for the chapter. If you have any questions, again, make sure you give me a yell through email or contact me through ICC's email, and I'd be more than happy to basically help you with anything you might have. We'll see you next time.